Hi, in this tutorial, I'm going to cover the CCSP domain 4, which is going to discuss the cloud application security. Please subscribe to the channel if not yet done and enable the bell icon. Training and awareness for the application security. In the cloud deployment and the development environment, it is heavily dependent on the APIs to support the automation and on demand access through the network. So the APIs helps to integrate the application to application for smooth integrations. In the cloud, it is mostly accessed through the web interfaces where the CSP makes it available through the APIs, and hence it becomes more important to offer the REST APIs, SOAP APIs, and to consider the application security for these APIs while we are going to access, manage, and control the cloud resources through these APIs. Common pitfalls: the migration and portability issues. The application which were developed for the traditional IT, these cannot be forklifted or cannot be lift and shifted to the cloud environment. So we will need to assess, we need to identify the risk and redesign the applications to apply the security controls, reconfigure, or even redevelop your security controls to meet the cloud security requirements. Integration issues. We have performing the systems and application integrations without the full access to all supporting systems, and the services that can be very complicated as not in full control, because it is not similar to the traditional IT environment where we have full control, while in the cloud we do not have full control depending on the cloud deployment, depending on the service model of the cloud. It has several issues. Also, the complexities and the integrations. The CSP's APIs should be used to reduce the complexity. APIs that are CSP's way of providing just enough control to the customer to facilitate the integration. So just to reiterate that you do not have a lot of controls in the cloud, and hence you need to rely on the just enough APIs which just provide the enough just enough control to the customers. Cloud environment challenges. uh, we have different deployment models in the cloud, like public, private, community, and hybrid. We have different service model: IaaS, PaaS, and SaaS. Which is being leveraged is the most often PaaS for the pure application development project, but may also include the IaaS deployment, because the service model determines how much access to the systems, logs, and information your development team has. Insufficient documentation, because new features, new fixes keep coming from from the CSPs, and it is very often that the documentation lags the speed of innovation or speed of the new service updates or patches, new releases. Hence there is insufficient documentation that we have in the cloud. Common cloud vulnerabilities like access control, internet related vulnerabilities, data storage, and usage related vulnerabilities. We have on demand self service means that the cloud user can access the cloud services. And here the identity and access management becomes the critical concern. Essentially, to implement with the principle of least privilege, strong authentication by periodic re-authentication, management plane need to be protected with the strong authentication. This is where we need to consider the access controls. Internet related, the broad network access means that the cloud resources are accessible by the users via a network. Hence, there is a common internet which is in use. and the internet related vulnerabilities like DOS attack or MITM, which are the major considerations in the cloud computation. Data storage, the rapid elasticity, that the systems scale up and down as necessary to support the changing in customer demand. Unrelated tenants might be using the same storage device, and hence here the CSPs generally have a strong logical separation between tenants and their data. So it is always consider the encryption when it comes to the data storage. If at all the encryption is not possible, then at least we should consider the obfuscation and masking of that data. Usage related vulnerabilities, we may have different vulnerabilities in the binaries, in the libraries which are being used to measure the services, that you pay for what you use, nothing more and nothing less. The system and application vulnerabilities allows any unauthorized party to misuse, maybe the party X is not authorized to use these services because these are the paid services, but there is vulnerability which he might have exploited, and maybe he or she is using your data, your account to use the computing power. But there might be some vulnerabilities, like you might have heard about the cryptojacking, which is a form of the malware that steals the computing resources and use them to mine for bitcoins or the other cryptocurrencies. So the cryptojacking, which is a form of the malware that steals the computing resources. So the REST and SOAP, in terms of the cloud deployment, we have both the REST and SOAP. This works on the HTTP, easy to implement. The REST supports the JSON, YAML, and XML format. The faster than the SOAP, and SOAP is basically this also works on HTTP, supports only XML that can be used where the REST cannot be. SDLC process, it is important. You will certainly going to see at least few questions from this topic in the exam. It is important that you consider the security at each and every stage of the SDLC, because here in the planning phase, all the business requirements should be defined, risk should be identified, cost benefit analysis is done, project timeline, project very high level requirements and project cost, and present it to the management. So after the agreement with the management, we present the project specific risk to the management, and then we move to the defining phase. In this phase, we clearly define the requirements through the requirement specification document, define the business requirement, feasibility studies we have to do, the stakeholders input from the planning phase to document them clearly, define the product requirements, and define the application security requirements as well in this phase. When it moves to the designing phase, in the designing phase, we have the specifications of hardware and system requirements, which helps to define the overall architecture, and this take the product requirement to turn them into the design. The developers who are involved, the architects who are involved, and the any other technical staff create the high level system here, and the software designed to meet each identified requirement. The most important is that the threat modeling, which is to be done in this phase. So you may see some questions related to when exactly the threat modeling is performed in SDLC. So which phase it is where the SDLC is performed. So it is the designing phase when we have to perform the threat modeling. Then we have the development phase where we divide the work into the modules and actual coding starts. This breaks into the different teams and assign the module to the different team. Usually the longest phase in the SDLC, because the planning, defining, and designing, these takes lesser time, and the development is the pure implementation phase. peer reviews the functional testing of the module and the security test to avoid the aggregation of the issues that we have to perform within the development. This is basically the unit test and all, because unit test goes along with the development. When we move to the testing phase, this is more related to the functional test, when the software has to be tested against the requirements, like integration test, system test, user acceptance testing. This is the main gate between the development and the customer. Careful creation of the test plans, and those test plans has to be reviewed with the stakeholders. Maintenance phase, it is the continuous monitoring and updates, as and when the updates are needed. For example, if bug need to be fixed or any patch is required to fix the security vulnerability. So this is where we have the deployment and maintenance phase. We have the alpha, beta, and general availability, are the different stages in the maintenance phase. If we are directly interacting with the customers, there are two methodologies here. One is basically the waterfall methodology. Another is agile. So in waterfall it is more rigid. For example, it starts from the planning. The planning has to be finished first, whether it is for 1 month or 2 month. The definition of the product has to be done first before we move on to the designing phase, and the designing has to be finished first before we start implementation. While in the agile, it is as the name suggests, it is more agile. We have different sprints, and in each sprint, it could be 1 week, 2 week, 3 week, 4 week. We have different work to be picked up as part of this sprint, and it has to be planned, defined, design, development, and testing. And it can, based on the customer feedback, it can even go to the production sometime, depending on, or even a combination of some sprints. So it depends on the customer feedback and the MVP, minimum viable product, whether this can be deployed in the production. Common vulnerabilities during the development, we have injection. So we have OWASP top 10. So we are not going to discuss all top 10 in this slide. The most critical security risks to the web applications, this list is particularly relevant to the cloud applications, because the cloud applications are mostly on the web based. The injection is basically when a malicious actor sends the untrusted commands or inputs to the application. The vulnerable application process the untrusted inputs because it is not actually properly performing the input validation which is recommended. So what kind of injections are there? SQL injection, code injection, and the cross-site scripting. Broken authentication, it is when the attacker is able to bypass the authentication mechanisms and allowing the attacker to assume the identity of the attacked user, thus granting the attackers the same privileges as that user. So what are the recommendations? Basically, the multi-factor authentication, we need to perform the session timeout, brute force login attempts need to be avoided or need to be tracked. We need to have TLS in place, protect session IDs, and the web application firewall to protect the sessions. Sensitive data exposure, we have on the web application side, on the web server side, we have several sensitive data, which is, for example, your PII, your credit card data, or some other sensitive data from the user side, which needs to be protected from any sensitive data exposure vulnerability. Basically, the encryption we need to enforce. XML external entities, XXE, it is when the attack occurs when XML input containing a reference to an external entity, the the same input is processed by the application without thorough parsing on that. So it is basically what are the harms from this vulnerability: data theft, port scanning, and DOS. So these are the kind of impacts due to this vulnerability. Security misconfiguration. Why it is happening here. The use of the default credentials, for example, if the new device is there and there is a default credentials like admin is username and admin is the password, so it is the misconfiguration, and we may have the insecure configurations on the system. The system may be unpatched, it is not up to date for the open vulnerabilities, and hence this becomes the vulnerable. So it is always recommended to keep the system updated and change the default credentials and harden the configurations always on the system. Cross-site scripting. It is the cross-site scripting. It enables an attacker to inject any untrusted code, like a malicious script, into the web page or the application. This can manipulate the output, redirect to the malicious site, or the attacker's control over the user's web session. It is always recommended for the to avoid the cross-site scripting, perform the input validation and sanitize all the inputs which are being received by the web application before it is being processed. It is recommended to perform those checks on the client as well as on the server. Server is the most important, of course, but it should be performed on the client side as well. Insecure deserialization. It is basically the impact is the remote code execution due to this vulnerability, and this can happen. Basically, the serialization is the process of the breaking down an object into the stream of the zeros and ones, while the deserialization is the inverse operation of the reconstruction or a series. Insecure deserialization occurs when an application or API takes an untrusted stream of bytes and reconstruct it into the potential malicious file. So this is more dangerous. Putting the machine code and reconstructing the code, the malicious code using that. Insufficient logging. Because you may not be able to have alerts if you do not have the sufficient logging. So it is important to have the sufficient logging in place there, so that we have a good number of alerts and which can be monitored. For the cloud risks, just go through the ANISA benefit, risk, and recommendations for the information security. The link for this document is provided in the video description. You can also refer to my video on the cloud risk, explaining the ANISA document. Threat modeling, it is again where when it should be performed in the designing phase. Stride is the method that can be used to perform the threat modeling. So what could be the threats? Like Stride itself is the full form of this Stride is here in the first column, and this mitigation is in the second column. So what is a spoofing? It is an attack during which a malicious actor assumes the identity of another user or any system by falsifying the information. So how can we protect from this threat? By putting the proper authentication in place. While the tampering, it is an attack on the integrity of the data by intentional or malicious manipulation of the data. So integrity check is the mitigation plan. It could be in any form. Repudiation, it is the ability of an party to deny that they are responsible for performing some action. So the repudiation threat occurs when the user claims that they did not perform an action and no other party is able to prove otherwise. So how to mitigate this? We need to have non-repudiation in place, and that can be achieved through the signatures and the cryptography. Information disclosure. Information, this is basically what happens during the data breach. Information is shared with someone who should not have access to it. So the confidentiality is the one, maybe encryption that you can apply on that information. Denial of service, we need to have high availability, HA, redundancy, and fault tolerance to protect against this. Escalation of privilege, though this is because this is E and this is the last character of stride, but it is the most important because escalation of privilege, it occurs when an unprivileged application user is able to upgrade their privileges to those of the privileged user, like an administrator. So it is a very important threat to consider, and must be mitigated always. So authorization is the mitigation, so authorization has to be implemented properly. Configuration management and versioning. So versioning plays the vital role here. The configuration management, when the process of tracking and controlling the configuration changes to the system and the software, and at the same time the versioning of the open source or of the third party softwares that we are using, or even the versioning of the software that we are releasing. So it is important to maintain that versioning so that we knows that which version, what all versions from the open source that we are using, and in this particular open source version these are the open vulnerabilities. So that becomes very important, to keep track of the versioning and the configuration management. There are certain tools here. Um, for example, the Ansible, Puppet, Chef, and Git. Of course, Git is the one which is being used to maintain the code, while the Ansible, Chef, and Puppet, these are mainly for the configuration management, because the configuration management, let's say if we have, let's say, Chef, and this is the server, and this is integrated with the software, and this picks the different versions, and we have different nodes like node 1, we have node 2, and we have node 3. So in that case we need to run the chef agent here, ca1, we need to have ca2 chef agent 2, then we need to have chef agent 3, and the chef server and chef agent will communicate, and this chef server will pick up the new software version from here, from the repository, and will deploy on all the nodes, node 1, node 2, node 3, with the help of the chef agent on all these nodes. Cloud software assurance and validation, we have functional testing. This is primarily to validate all the functional aspects of, or the features or the components of an application, rather than the complete application as a whole. For example, these functional testing includes like unit testing, component testing, integration testing, regression testing, etc. We have to furthermore here like black box testing, when the user doesn't know, or the tester doesn't know what is there inside, what is the design. They just know that this is the input and this should be the output from this black box. While in the white box, so we have two aspects, um, white box and black box. So in the white box, in the black box, the tester doesn't know anything. They knows the input and an output. Something has to be inputted and something has to be outputted, well-known output. And in the white box, they knows the internal design and how the system works. They have the internal knowledge of that system. That is how this white box and black box differs. The security testing methodologies, the SAST, static application security testing, it is a kind of static code analysis and a security testing technique that is involved assessing the security of application code without executing it. So point to be noted here, the SAST is performed without executing the code. while the dast is performed after execution. So we need to uncover the vulnerabilities by running an application and simulating an attack against it. Then only we can perform some kind of testing in the dast case. Vulnerability scanning, it is a process of assessing an application or the system for known weaknesses. This process usually involves using a tool to run some tests, for example, on the servers, networks, and the applications. And this server is actually well integrated with the NVD, which is National Vulnerability Database, and this picks up the vulnerabilities from open vulnerabilities from there against that particular version of the open source OSS and version 1, for example, and against version 1, how many vulnerabilities are there in the NVD database, and this will show up that these are the vulnerabilities, and this is how this product can be impacted. In the penetration test, it is a process of conducting a simulated attack on a system or an application in order to discover some exploitable vulnerabilities. A pen test may be white box or even the black box as well, similar to the functional test. In the black box and in white box pen test, this is the same methodology. In white box, the pen tester would know how the system is designed, how system works, and what is going to be performed inside based on that input that is being provided, and how the output will be arrived. Similarly, in the black box, the pen tester doesn't know, much information internally, and they try to penetrate into the product. They try to perform some attacks, and they see that, okay, without knowing something, how the system behaves, and whether we are able to attack into the system. There is one more here. In addition to white box and black box, we have gray box penetration testing as well. So in gray box penetration testing, it is a mixed approach. They know some internal information as well, but not complete, as in white box, and they know some partial information, and at the same time, they perform the black box way as well. Use of the verified secure softwares. Here, the approved APIs. The APIs are, in terms of the cloud deployment. This is the most powerful mechanism by which the cloud providers exposes the functionality, and hence this becomes very important to maintain the security of these APIs, for the overall security of cloud environment and their applications. Consuming or leveraging any unapproved APIs can lead to any insecure application and compromised data. Testing in APIs security includes including the ensuring that the REST or SOAP APIs using the secure access methods, enabling the sufficient logging and encrypt the communication wherever it is applicable. Similarly, on the supply chain, it is increasingly common for the companies, when they work with the different organizations, different companies, and they get the components from the different companies, they integrate them together, um, using their supply chain management. And it is very essential that the organization consider the security implications whenever they use the software component outside of their organization control. Third party software management, access your organization's use of third party to manage, that is to assess your organization's use of third parties to manage the part of your software. For example, the third party patch management, the third party encryption software, and the third party access management software solutions that we are using in our infrastructure, in the cloud, in the supply chain management, etc. So we need to assess what kind of security it is there, what was done to during the development, what is done before the release of these softwares. So we need to verify those things before actually we apply those softwares in our production environment. Validated open source software, in the cloud environment, the developers heavily rely on the open source applications, libraries, and tools to build their own software. And this is often considered to be more secure than the closed source software, because we know that the all the open source software that we are using, these are well known, well tested by the different communities. These are well verified softwares against any vulnerability, against any other risks. So it is good to use those, but always validate the source from where actually you are downloading those softwares before you integrate them within your product. Supplemental security components. WAF, it is a layer 7 firewall. Basically, it analyzes the HTTP traffic, and also it is effective against any DOS, DDoS kind of attacks. DAM, the database activity monitoring, it is a layer 7 monitoring device that is again protecting against any execution of the SQL commands, which can lead to the SQL injection or any code injection kind of attacks. XML gateway, which can transform or enable the exposure of the sensitive data as API. And also this gateway can either be hardware or software. It can implement the control as the data loss prevention. Firewall that can be configured across the different service models. It can be distributed or configured on SaaS, PaaS, IaaS. It can be owned, operated by the provider or the outsource to the third party. Firewall in the cloud need to be installed as a software which is host based. API gateways, it filters the API traffic. It can be installed as a proxy. It can implement the access across the controls, rate limiting logging metrics, and security filtering. So it is all related to the supplemental security components which we usually buy from any other suppliers or vendors to before we deploy them in our cloud deployment. The cloud application architecture, we have the cryptography, which is the important aspect for the data which is in the cloud. Um, because encryption is the central component of every cloud security strategy. This plays a huge role in securing the data at rest and data in transit. Application encryption at rest involves the encrypting the sensitive data at the file subjects, the database volumes, or even the entire instance level. Also, the encryption at the file or object or the database level allows the customers to encrypt only their most sensitive information or the data that has specific regulatory requirement. In the encryption in transit, typically it involves either TLS or the VPN technology. So TLS encrypts the traffic within an application and between an application and a client's browser. Sandboxing, it is a process of isolating an application from the other application and resources by placing it in the separate environment. That is known as the sandbox. So when we isolate the application, the errors or the security vulnerabilities in that application are also isolated from the sandbox. Um, Thus, the protecting the rest of the environment from harm. The virtual machine serves as a great mechanism for the cloud and the cloud customers to create the sandbox, just to be mindful that your virtual firewalls, access controls, and the other configuration settings appropriately isolate traffic from your sandbox VM to the rest of your environment. Application virtualization, it is a process of encapsulation. For example, when you run your Windows application in the Mac, it is the application virtualization. So because that is actually encapsulating your Windows application into the Mac environment, and hence it can run on the different platform. And this is where the application virtualization comes into the play, because this virtualization environment can provide the Windows application to the same environment which is required to run on the Mac platform. Orchestration is a process of bundling and integrating two or more applications or services to automate a process. The objective of the orchestration is basically the automation, to align your technology stack with a particular set of business needs or requirements. By automating the configuration and the management of the disparate applications and services, orchestration allows the organization to spend less time managing the important yet time intensive tasks. Federated identity, it is this diagram is taken from the Azure Federation, federated identity. So what is federated identity means? It means the user's identity on one system is linked with their identity on one or more other systems. A federated identity system allows the reciprocal trust, access across unrelated systems and between the separate organizations. And who is the identity provider? The identity provider means it is a trusted third party organization that stores the user identities and authenticates your credentials to prove your identity to the other services and applications. So in this diagram, if we see in this here we have the federation provider and we have the identity provider. Okay, and being a normal user on the browser, what we are going to do is we are going to get the token from ADFS, which is the identity provider, and this ADFS will give you the token which you can in turn submit to the federation provider, because federation provider and the identity provider, they have already trust each other. Okay, and similarly the federation provider and the service provider, the SaaS application provider, they also trust each other. Okay, so in that case, when you submit the token, when you submit the token to the federation provider, um, you get the another token which you can submit to the SaaS application. Okay, to get access. And this is why the federated identity comes into the play, because we may have SSO. Sometimes we got confused with SSO, the single sign on. In single sign on, it is a one time login, but here in the federated identity, it is more scalable than the SSO, and you may need to provide your credentials. You may need to log in more than once, because as and when you get access to you try to access the different services, you again need to get the token so that you get access to that new service. So we have different standards which are useful to implement the federated identity. First is the SAML, so usually SAML 2.0, that is in use, and then we have OAuth, and then we have OpenID. So SAML 2.0 is the most commonly used, and it is based on XML framework for the communicating user authentication, entitlement, and the attribute information. While the OAuth is an open standard that application can use to provide the clients with the secure access delegation. In other words, the OAuth works over HTTPS and issues the access token rather than using the credentials like username and password to authorize the applications. You also might see OAuth in action with the applications like Google or Facebook, um, which uses the OAuth to allow you to share the certain information about your account with the third party without sharing your credentials with that third party. An OpenID is an open standard and decentralized authentication protocol that allows the users to authenticate to participate to participating applications known as the relying parties. Also, the OpenID allows the users to log in into the multiple separate web applications. So there are different providers like Azure Active Directory, AWS IAM, Google Cloud Identity, Ping Identity, Okta Identity Management, things like so they are the ones who are the identity providers. Other IAM solutions, single sign-on. Single sign-on, commonly referred as SSO, is an access control property that allows a single user authentication to be used to authenticate or to sign on to the multiple separate but related applications. The SSO allows a user to authenticate a single time, as I discussed in the previous slide, because you just need to provide your credentials once, and once you're authenticated, you will have access to all the applications by default. Sometimes it is risky, and sometimes it is more difficult as well, because in cloud you have different platforms and you have different cloud environments like hybrid or the other clouds where the single sign-on might not work, and there you need the federated identity. SSO sounds like the federated identity, and while they are related concepts, actually they are not the same, because SSA enables a single authentication to allow access to the multiple systems in the cloud, while the federated identity, every time you need access to the new service, you need to provide your credentials to get access to that. Then we have multiple authentication, multi-factor authentication. So this is MFA. Multi-factor authentication is something where we need knowledge, means something you know. We need possession of something you have. It could be hardware, it could be OTP or SMS. Inherence, which is something you are, means something you are means the biometric. Okay, something you know, something you have, something you are. And the location, so location is the user's physical location, means the this is being used in the attribute based authentication. So if you are present at a particular location, then only you can log into that particular service. Cloud service broker, cloud access security brokers, forward proxy. So what is CASB? It is a software application that sits between the cloud user and the cloud. So for example, you are the actor, who wants to access to a particular service, and we have CASB in between. Okay, and then we have maybe the cloud, where it could be SaaS, it could be IS, and it could be PaaS. Okay, so in that case, this CASB, the cloud access security broker, sits between the cloud user and the cloud service and applications which are offered from the cloud. um, A CASB may be used to mitigate high-risk security events or to prevent such events altogether by enforcing some security policies, stopping the malware, and alerting the security teams of potential security events. Because this is going to obey your corporate rules and your company security policies, etc. So there are different aspects here. One is the forward proxy, reverse proxy, API proxy. These are the kind of implementation in the forward proxy. This type of CASB that sits close to the user and on the user's desktop, laptop, or the mobile phone, and uses an encrypted MITM technique to securely inspect and forward all the cloud traffic to for the user. In the reverse proxy, this type of CASB sits close to the CSP and integrates into the identity services like Okta or OneLogin to force the user's traffic through the CASB for inline monitoring. Um, so the forward secrecy in the forward secrecy, the CSB sits on the client side, while in the reverse proxy, the CSP sits on the cloud side. And on API, there is one more, which is API based. This type of CASB allows the organizations to enable the CASB protection to any user on any device from any location. This kind of CASB monitors the data within the cloud itself, and rather than on a proxy at the parameter. Not all cloud applications provide the APIs, and that is why it is a challenging task to implement the API based CASB. Because if one cloud provider is providing those APIs and the other is not, then you may end up into the cloud lock-in. That is the another risk and the challenging with that. With this, I will conclude this CCSP domain 4. Thank you. I hope you liked the content in this tutorial. Please tell me in the comment section. Thank you. Please like, comment, share the videos. If not yet subscribed, please subscribe to the channel. Thank you.